This video will serve as a brief overview of the LFI 110, ODM's live fiber identifier accessory for RP450, RP455, and RP460 power meters. When used correctly, the LFI 110 allows for identification of core power and of 2 kHz tone on single-mode jacketed fibers. The device has been designed to work on the following: 250 micron fiber, 900 micron jacketed fiber, 2 mm jacketed fiber, and 3 mm jacketed fiber. When live fiber identification was invented, equipment manufacturers began to provide standalone units that could only identify live fibers and indicate if there was a tone present. Many equipment manufacturers still provide these devices, which only perform those limited functions, for over $1,000. ODM's approach to live fiber identification includes the use of an accessory that attaches to our power meters. Using this system, technicians can utilize their power meter for traditional dB loss and dBm power measurements, then attach the LFI 110 and perform live fiber identification. By converting a technician's existing power meter into a live fiber identifier, ODM provides twice the functionality for about half the cost of competitors' fiber identification units. To connect the LFI 110 to a power meter, first remove any adapters currently attached to the power meter. The power meter is inserted into the clips on the LFI until the head of the power meter meets with the housing of the LFI. The unit should fit together very tightly. The LFI is intended to be used while the power meter is in dBm mode. This will allow the user to view the absolute power level of the light traveling through the fiber core. If the power meter is not already in dBm mode, press the dBm button to change the mode. To demonstrate core power measurement with the LFI and power meter, I will use a DLS355 dual laser source. Any of ODM's other single-mode light sources will work as well. This DLS355 is set to the 1550 nanometer wavelength and has an output power of around -3 dBm. The fiber plugged into this DLS unit is a single-mode fiber with a 3 mm jacket. I'll simply fit the jacketed fiber into the LFI, making sure to push the fiber all the way to the back of the channel, then pull the trigger. Please note that the fiber must be inserted into the LFI so the direction of the optical signal matches the arrow on the unit. The reading on the power meter will indicate the power of the laser at that point in the fiber cable. All readings taken with the LFI this way will be around 30 dB less than the actual core power. For instance, if the output power of this light source is -3 dBm, I can expect to see a reading of around -33 dBm when I use the LFI at this distance. The typical accuracy level when identifying core power is plus or minus 2 dB. Since ODM power meters can measure core power as low as -60 dBm, they can be used for live fiber identification at distances up to 100 kilometers away from the light source. To identify live fibers using a tone, we'll use the same DLS355 laser source. Any light source that modulates at 2 kHz can be used. I'll make sure the light source is turned on and press the 2 kHz button to begin the modulation. When the light source is outputting the 2 kHz tone, it is simply flashing the laser on and off at a rate of 2,000 times per second. ODM's power meters are designed to beep loudly when a 2 kHz modulation is detected. In this setup, I have my DLS355 modulating at 2 kHz. The laser is going through this test jumper with a 3 mm jacket, then through this 5 km reel of 250 micron fiber, then through this 2 mm jacketed fiber at the end. I'll start with the 3 mm jacketed fiber. If the power meter beeps, I will know that I'm clamped onto a fiber that has a 2 kHz tone on it. Now I'll do the 250 micron fiber. And now the 2 mm jacketed fiber. Notice that the power meter in LFI will recognize the tone at significant distance. Even with this 5-kilometer reel between the light source and power meter, the unit still beeps. In fact, ODM's power meters with the LFI attachment can identify the 2 kHz tone up to 20 kilometers away from the light source. The functionality of the LFI with the power meter can be very helpful in dense patch panels. If the technician cannot unplug fibers from the panel in order to find out which one needs to be replaced, they can use the LFI to identify which fiber has the modulated signal.
Find out more at Vicom's website.